If you look at this problem, there's a numerator and there's a denominator, right? Numerator is sec x minus tan x and denominator is sec x plus tan x. You are most tempted to use u by v rule, and you will not have much problems also if you use u by v rule. Okay, if you use your u by v rule here, then next maybe you will get 4 or 5 extra steps. But the step that I am going to show you here, you can do it a little more easily, and this is a little more sophisticated manner of doing. Okay. Um, but however, what you see here is what I see in the proof is that that manner is not required, because I have, you see the square of the denominator here, sec x plus tan x whole square. It seems that because, and in u by v rule, if you remember, you have a square of the denominator, isn't it? V square, and the denominator here is sec x plus tan x. So it seems that you will have to, you can, it will be easier for you to differentiate directly by u by v. So it seems. Okay. So what I'll do is I'll differentiate directly only. No point, because I see this denominator here. There was another better, much better way, but the expression here tells me that it is better to differentiate directly. So given y is equal to sec x minus tan x divided by sec x plus tan x. Therefore, dy dx here is, use u by v rule. Consider this entire function as u. Consider this entire function as v. So v ddx of u minus u ddx of v whole divided by v square. So you already got, if you see in the proof, you have sec x plus tan x square. You've got the denominator here. Now let us simplify the numerator, differentiate and simplify the numerator. So you have sec x plus tan x and ddx of sec x here is sec x tan x, and ddx of tan x, you know, is sec square x minus sec x minus tan x. ddx of sec x is sec x tan x minus ddx tan x plus, sorry, not minus, but plus ddx of tan x is sec square x divided by sec x plus tan x whole square. Now, sec x plus tan x, from here, you can take sec x common, and you have tan x minus sec x minus sec x minus tan x sec x into sec x plus tan x, and you divide the entire thing by sec x plus tan x square. Now what you see here is, this is your a plus b form, and this is your b minus a form, right? That is b plus a into b minus a form, b, which is equal to, if you multiply, you will get b square minus a square. Similarly, you have a minus b form here and a plus b form here, right? Which is a square minus b square if you multiply. So therefore, you have sec x into tan square x minus sec square x right, minus, then you have sec x into sec square x minus tan square x. whole divided by sec x plus tan x square. Okay. So now here you can take a minus sign common. So you get sec x into sec square x minus tan square x minus sec x. Now see, they can write this as sec square x minus tan square x. Why? Now what is sec square x minus tan square x? Sec square theta minus tan square theta is what?
1, sir.
1. So we'll put it. So minus sec x into 1, and you have minus sec x into 1 divided by sec x plus tan x whole square. And that's what we get the required result. What we had to prove, minus 2 sec x by sec x plus tan x. There were actually much better ways of differentiating this, but the problem is that in your proof part, they have given sec x plus tan x. Sec x plus tan x was here also, and sec x plus tan x was here also. So that is why there was nothing much that I could do than differentiate that. Though if you change everything to tan and cos, you know what it will come to? It will come to 1 minus sin x by 1 plus sin x. And I have already shown you the differentiation of 1 minus sin x by 1 plus sin x earlier, right? So you could have differentiated by that way also. Or what you could have also have done, if there was no sec x, you could have multiplied the numerator and denominator by sec x minus tan x. Then what would have happened? This would have become sec square minus tan square, isn't it? Which is equal to 1. And the numerator you would have sec x minus tan x whole square. Now which would have become very easy to differentiate, right? So that is what we'll do the next problem. If fx is equal to 9 sin x plus sin 3x, find f dash pi by 3. So given here, 9 sin x plus sin 3x. Okay. F dash pi by 3 means what? What does f dash mean? F dash means the derivative or the differentiation of fx, right? So therefore, if you write f dash x, it means ddx of, that is the first derivative of 9 sin x plus sin 3x, right? Which is, now if you differentiate this, you get 9 ddx sin x plus ddx sin 3x. Now you can separate here, ddx of sin x is cos x, and ddx of sin 3x by what did we know about sin ax plus b? 3 cos 3x, right? So we have got f dash x, therefore f dash pi by 3. F dash pi by 3 will be what? Just put x is equal to pi by 3. Yeah, in this, you have 9 cos pi by 3 plus 3 cos 3 times pi by 3. Now cos pi by 3 is how much? Cos 60, which is half, plus 3 times cos pi, because this 3 will cancel. So you get 9 by 2 plus 3 times. Now how do you find out cos pi? Write cos pi as 2 into pi by 2 minus 0. Remember your negative and associated angle? Right. This is the way we write. Now what happens? 9 by 2. Now see, there's an even multiple here, so cos will not change, cos will remain cos. And which quadrant is this in? This is in the second quadrant where cos is negative. I'll put a negative sign. 3 cos 0. And cos 0 you know is 1. So 9 by 2 minus 3, which is 9 minus 6 by 2, which is 3 by 2. That's it. Next problem here is, if y is equal to sine root sine x plus cos x, find dy dx. Okay. Now we'll use chain rules here because you see this is a composite function. And then one function is inside the other. What is the main function here? The main function here is sine. And what is the function that is inside this function? It is root sine x plus cos x, right? So we have actually, we can split this into three functions, right? If you use u, v, and w, you can split this into three functions, but we'll differentiate directly. You see. So here, given y is equal to sine root sine x plus cos x. Therefore, dy dx ddx of sine root sine x plus cos x. Okay. So now, first we differentiate this sine to get cos. And what is inside this sine? Root sine x plus cos x. Next, what we have to differentiate? Next, we differentiate this radical, right? If you differentiate this radical, how much will you get? ddx of root x is 1 by 2 root x. This is 1 by 2 root sine x plus cos x, right? Into what is inside the radical? Sine x plus cos x. So into the ddx of sine x plus cos x. Okay. So now this is cos root sine x plus cos x divided by 2 root sine x plus cos x into, now ddx of sine x plus cos x is ddx sine x plus ddx cos x. Which is equal to cos root sine x plus cos x divided by 2 root sine x plus cos x, and you have ddx sine x here is cos x and ddx cos x is sine x. Okay, so what this is ultimately what you are getting, and this should be your answer. Okay, this is how you differentiate. And then, and the next problem is the last for this. Now after this we'll start how to differentiate log functions. Okay, problem here is y is equal to tan x by 2. Prove that dy dx is equal to 2 by 1 plus cos x. So we start with y is equal to tan x by 2. Now, if you see in this problem here, you have tan here, and dy dx is in terms of cos, right? So you can change tan to sin x by 2 by cos x by 2 and then proceed. Okay. Um, or without even doing that, you can do. But let's do that, because we see that dy dx is in terms of 2 by 1 plus cos x. But if you one more thing which you want to remember is that if you differentiate tan x by 2, you'll get sec square, isn't it? Differentiation of tan is sec square. Even sec can be changed to cos. So you can proceed that way also. Okay, both ways you can proceed. So which way would you like me to show you? This way or
The
after
cos of
cos? Okay, so let's proceed with that way. You can write this as sin x by 2 by cos x by 2. Okay, so now what you do here is you uh, multiply the numerator and denominator by cos x by 2. You have 2 cos x by 2. So you can write it this way, right? You can write it this way. So now, because what have we multiplied this by? You understood this step, 2 sin x by 2 cos x by 2 cos square x by 2. No problem here.
yes, sir.
Okay. So this is multiple angle formula now in the numerator. This becomes sine of x only. That is sine of twice x by 2, isn't it? And the denominator, 2 cos square theta is 1 plus cos 2 theta. So you can write this as 1 plus cos x. So once you have done this, now you can differentiate this very easily. Therefore, dy dx, you can use u by v rule, dx sin x by 1 plus cos x. So you have, if you use u by v rule, um, you will have 1 plus cos x into the ddx of sin x minus sin x into the ddx of 1 plus cos x divided by 1 plus cos x whole square. Now you can 1 plus cos x ddx sin x is cos x minus sin x, and ddx 1 plus cos x is 1 minus sin x. Sorry, it's only some minus sin x, not 1 minus sin. It's 1 plus cos x is 0 minus ddx cos x, which is minus sin x. And then you have 1 plus cos x whole square. Okay, so now you can multiply this, you get cos x plus cos square x, and you get plus sin square x divided by 1 plus cos x whole square. Okay, so now this cos square x plus sin square x, you combine this to get 1. So you get 1 plus cos x in the numerator. Okay, um, divided by 1 plus cos x whole square. Okay, and I think I have forgotten to write this 2 somewhere. So it seems, oh, 2 tan x by 2 this was, not tan x by 2. Okay. This question was y is equal to 2 tan x by 2. So just press add a 2 everywhere. So instead of this 2 here, we put it in curly brackets here also, and this 2 we put here also, and so that we get a 2 here. And while we are differentiating, we take this 2 outside. Okay, and this 2 here remains also. Okay. This 2 also remains here. This 2 remains here, and this 2 remains here also. Okay, so that now 1 plus cos x will cancel here, and 1 plus cos x will cancel in the denominator. So that ultimately you are left with 2 by 1 plus cos x. Simply. That's it. Okay. Now we move on to the next part, which is differentiation of logarithmic and exponential functions. Logarithmic and exponential function. Now, how to differentiate logarithmic and exponential functions by chain rules. That is what we are going to learn here. Okay, but before that, you must know the results. Okay, the first result that you are supposed to know here is that ddx of log x. That if you differentiate log x, that is natural log, you get 1 by x. Okay, this result you must remember. And the next result that you must remember here, yes, I think that is the result that you must remember. For the time being, we'll do logarithmic first, and then we move on to exponential. Okay, you just remember this. Also, you must note here that this also can be written as ddx of ln x, natural log, is equal to 1 by x, right? Also, you must note here that if I give you a differentiation like this, ddx of log x to any other base, which is not e, okay, then how do you differentiate this? Here you had natural log. This is not a natural log, log x to the base a. Okay, how to differentiate this? You will change the base to natural log. How do you remember the base changing formula for log? The base changing formula for log was log x by log a, isn't it? That is now the base is e for both. Now this part, the denominator part, is a constant, so you can take it out of the differentiation. So 1 by log a to the base e into the ddx of log x. Now you know the differentiation of natural log is 1 by x. So this becomes simply 1 by log a to the base e into 1 by x, which is 1 by x log a to the base e. Any question here?
No, sir.
I hope this is clear. Remember distinction between differentiation of natural log and differentiation of log with the base e. Okay, but this is not a formula actually. Okay, the only formula that you are required to remember is this for this. Okay, this is not a formula. This you can very easily get from this. But a very important result, the note part. So let us do the next part of the question problem. Differentiate the following functions. First function given to you here is log. Very important, this one. Okay, take note of this because later we shall be using the integration of this also. Log x plus root x square plus a square. This is a very important problem. Next one here is log root 1 minus cos x by 1 plus cos x. Third is log, and again you have a log. Okay, let me not give brackets. Let just without, I'll understand this without the brackets. Log of a log of a log x. Okay, So you have how many logs? 3 logs. You have inside this log, you have these 2 logs. Inside this log, you have this log. Okay. So that is what. Let's take some more. Next is number 4. Again, an important one, log sin x. Okay, so try to remember this and try to remember the differentiation of this. We shall be coming back to this later on. Next is cos log x. Next is log 3 minus 7x. Next is log cosec x minus cot x. Okay, and next is sin log cos x, and next one is log 1 minus x square by 1 plus x square, and number 10 is sin log 3x. All these. Let us see. First one. You have log x plus root of x square plus y square. So let I start by saying that y is equal to log x plus root x square plus a square. How to differentiate this? Now you see there is a log here, and inside the log you have another function, right? So you differentiate by composite function or chain rules. So therefore dy dx will be, first you differentiate because log is the main function here. So you differentiate log first. What is the differentiation of log? dx of log x, is 1 by x. So after, if you differentiate this, you will get 1 by whatever is within the log, x plus root x square plus a square. And then you differentiate what is within the log, that is into the ddx of x plus root x square plus a square. And this is done. Now we shall simplify this. So you have 1 by x plus root x square plus a square, into here you have ddx of x plus ddx of root x square plus a square. So you have this within brackets 1 by x plus root x square plus a square, and you differentiate this, you get 1 plus. Now how do you differentiate root x square plus a square? Again by chain rules. So first you have a radical, so you differentiate the radical. What is the ddx of root x? It is 1 by 2 root x. So 1 by 2 root x square plus a square into the ddx of x square plus a square. Okay, which is equal to 1 by x plus root x square plus a square into 1 plus, see, ddx of x square here is 2x, right? ddx of x square is 2x and ddx of a square is 0 because it is a constant. So this becomes 2x by 2 root x square plus a square. Is this step clear to you?
Yes, sir.
Okay, so now what we do is we take the LCM within the curly brackets. Take the LCM within the curly bracket. LCM is root x square plus a square. So that in the numerator, you will get root x square plus a square plus x. Right? This is what you're going to get. Now what happens? You see that here this and this will cancel. You're only left with 1 by root x square plus a square. That's it. That's your answer. So the next one was log root 1 minus cos x by 1 plus cos x. Log root 1 minus cos x by 1 plus cos x. Now see, if you apply your u by v rule here, this is going to become a little complicated. Okay, so it is better to simplify this a little. So what do you know about 1 minus cos? Remember this result 1 minus cos 2 theta by 1 plus cos 2 theta? What was this result? Tan square theta, isn't it? So we'll write this as log root tan square half of the angle x by 2, right? So now what happens? You can, because you have a square inside the radical, you can remove the radical. You have log tan x by 2 simply. Now it becomes a cakewalk to differentiate. So therefore, d by dx is d dx log tan x by 2, which is, if you differentiate, first you differentiate the log. d dx of log, you know, is 1 by x. So this is 1 by tan x by 2. And then you differentiate what is within the log, tan x by 2. Okay. What do you have? 1 by tan x by 2. d dx tan x by 2. How will you differentiate? First to differentiate the tan to get sec square x by 2. And then you differentiate what is within the tan. So d dx x by 2. So what do you have? You have d dx x by 2, you know, is half. So you have sec square x by 2 by tan x by 2 simply. 2 tan x by 2. Sec square x by 2 by 2 tan x by 2. Okay. Now this can be simplified a little further. Even if you leave your answer here, it is no problem because you don't have to prove anything here. But I can show you a simplification. That is, if you change your sec to cos, what are you going to get? You're going to get 2. And if you change your sine to tan to sine and cos, you're going to get sine x by 2 by cos x by 2. And it's change your sec square to cos square into cos square x by 2. So what are you getting here? 1 cos cancels here. You simply get 1 by 2 sine x by 2 cos x by 2. And what is 2 sine theta cos theta? It is sine 2 theta. You simply get 1 by sine of twice x by 2, sine 2 theta, which is 1 by sine x, which is simply cosec x. Okay, so this is how you simplify this. Move on to the next one. The next one here is log x. Log x. Differentiate this. Dy dx is equal to d dx log x. How do you differentiate? First you differentiate this log because this log contains these two, right? So if you differentiate this log, you get 1 by log x. right? So outside your log, you have differentiated. Now you go to the next inside log. You go to this log. So you differentiate ddx of log x. Okay, so now ddx of log x. So now you differentiate this log. Okay, so you get 1 by log x. And then you go to the differentiation of this log into the ddx of log x. Okay, so you get 1 by log x into log x, and ddx log x is 1 by x. So ultimately you get here is 1 by x log x into log x. That's it. That's your answer. Okay, we move on to the next problem here. And the next problem that I gave you was log sin x, important one. Let y is equal to log sin x. Therefore, dy dx is ddx log sin x. You differentiate what is within the log, differentiate this log first. That is ddx of log sin x to get 1 by sin x. And then you differentiate what is within the log. And what is within the log? Only sin x. So now we shall write the result here. ddx sin x is cos x. And in the denominator you have sin x. You simply get a cot x. Important result. Okay, if you remember this sum, it will be beneficial for you in the times to come. Next you have I have given you cos of log x, number 5. Very similarly, we differentiate y is equal to cos log x. Would you try this, Devanjan? Would you like to try this?
So minus sin x and 1 by x.
Yes. It is a product of minus sin x, minus sin, only
Minus
sin
sin
x,
1 by x.
only sin x. We are differentiating this cos to get minus sin, but sin of what? What is within the cos? Sin log x, isn't
Log
it?
x.
And then into the differentiation of log x, right? So be very careful here. Now this becomes ddx log x is 1 by x, so you simply get minus sin log x divided by x. That's it. The next one here, number 6 that I have given you is log 3 minus 7x. Okay. Therefore, by dx. This is also very similar. Would you like to try this? Tell me. Log 3 minus 7x. First differentiate the log
1 by 3
3
minus
minus
7x.
7x. Next you differentiate what is within the log 3 minus 7x. And 1 by 3 minus 7x. What is the derivative of 3 minus 7x? You know, ddx 3 minus 7x.
The constant was 0 in that time.
ddx of ax plus b, if you remember, I told you was how much? ddx of ax plus b was a, right? So what is ax
Yes,
plus
sir.
b here? A here is minus 7. B here is 3. So this is simply minus 7. Understood?
Yes, sir.
Or you can distribute the differentiation. You can take ddx of 3 minus 7 ddx of x. This is also the way you can do. Clear? You'll get 0 minus 7, which is 7. Clear with this?
Yes, sir.
Move on to the next one. The next one here is log cosec x minus cot x. Now, this is also an important one. Take note of this. Okay. We'll be coming back to this. Cosec log cosec minus cot. Okay. Dy dx here is ddx log cosec x minus cot x. So how will you differentiate here? First, we differentiate the log, right? To get 1 by cosec x minus cot x. And then we differentiate what is inside the log, ddx cosec x minus cot x. Now we start our differentiation. So this is 1 by cosec x minus cot x. And the differentiation of cosec minus cot will be how much? You distribute the differentiation over cosec and cot. ddx cosec x is, what is the differentiation of cosec x? Differentiation of cosec x is minus cot square, isn't it? ddx cosec x is uh, minus cot square. And what is the differentiation of cot x? No, ddx of cosec is minus cosec cot. Yeah, even I got confused. ddx of cosec x is minus cosec cot. Okay, and ddx of cot x is minus cosec square. So minus of minus cosec square x. Okay, ddx of cot, remember, is minus cosec square. Okay, so now we shall simplify this. So we have here from the numerator, if you see, what can you take common? You can take minus cosec x common. So what are you left with? Cosec x plus cot x. Divided by, and here you have cosec x minus cot x. Okay. So this one here, cosec minus cot. So the sign in the question was cosec plus cot, not minus. Okay. So now if we differentiate this, you get a plus sign here, and finally you get a minus sign. You get a minus sign here. Okay. So what happens is that if you take cosec common, then only. So from these two, okay, if you take minus cosec common, you get cosec plus cot. In the denominator also, this is cosec plus cot. So this is cosec plus cot. Cosec plus cot. Okay, so you get minus cosec x you will get. And this is minus cosec and cosec plus cot x. So this is, these two now will cancel. Yeah, because you had a plus sign here and you have a plus sign here. So these two now will cancel. If you take minus cosec x from, your answer is minus cosec x. Okay. So the next question that I gave you here was number 8. Let y is equal to sine log cos x. Again, y will differentiate by chain rules. Sine log cos x. So first you have the sine function. So you'll differentiate this sine to get cos log cos x. And then you will differentiate what is within the sine. What do you have within the sine? You have log cos x. Okay. Next, cos log cos x. And now what you do? Here you have log first, so you differentiate log. What do you get? 1 by cos x. And then you differentiate what is within the log, and you have cos x within the log. So what you get here is minus sin x, dx of cos x is minus sin x into cos log cos x divided by cos x. And that is your answer. Okay. We move on to the next one here, which is number 9, given y is equal to log 1 minus x square by 1 plus x square. Okay, now this problem can be done in two ways. That is, you can use your chain rules, and then inside when you differentiate this 1 minus x square by 1 plus x square, you can use your u by v rule. Okay, this way you can do, that is, you can differentiate directly. Or I would consider maybe a little better way of doing this is that if you express the numerator in terms of the denominator, a little bit of manipulation I'll do. How? See, I have 1 plus x square here, right? So what I do is I write the numerator as 1 plus x square. But I don't have 1 plus x square. I have 1 minus x square. So I'll subtract 2x square from 1 plus x square. You understood this step? You understood this step? Because I wanted to express numerator in terms of the denominator. In the denominator, what did I have? I have 1 plus x square. That is why, see, I brought a 1 plus x square in the numerator. Understood?
Yes, sir.
The benefit of this, what is the benefit? Now what I can do is, I can separate this. That is, I can have 1 plus x square by 1 plus x square. And I can have minus 2x square by 1 plus x square. Okay, so that now this cancels, it becomes 1. Log 1 minus 2x square by 1 plus x square. Okay. Now you can be a little easier to differentiate now. So therefore, dy dx is equal to ddx of log 1 minus 2x square by 1 plus x square. First, to differentiate the log here, what do you get? 1 by 1 minus 2x square by 1 plus x square into the ddx of 1 minus 2x square by 1 plus x square. Okay. So now You simplify you take LCM in the denominator. Okay. And now you start differentiating this. Now, if you start differentiating this, see that ddx of 1 will become 0 minus, and then you have twice ddx of, because 2 is a constant, you can take it out, right? Is this step, did you understand this step?
Yes, sir.
Okay. So this is, now you have 1 minus x square by 1 plus x square. And here now you differentiate within this by u by v rule, you can differentiate. So this is minus twice of v ddx of u minus u ddx of v whole divided by square of the denominator. Okay. So we have 1 plus x square by 1 minus x square into minus 2. This becomes ddx x square is 2x. So 2x into 1 plus x square minus, you have x square into 1 plus x square, differentiation is 2x. And you have divided by 1 plus x square whole square. Now what you see very easily here is that this 1 plus x square and this single 1 plus x square will cancel, right? Now we just simplify. So you get 1 by 1 minus x square into, you get minus 4x minus, by minus 4x, because let me use a little step by step so that you can understand. So this is minus 2 we write, and then now you multiply this, you get 2x plus 2x cubed minus 2x cubed. Okay, divided by 1 plus x square, right? So now 2x cube is going to cancel here. So what am I going to get? I'm simply going to get a minus 4x in the numerator, and I'm going to get 1 plus x square into 1 minus x square in the denominator. And in the denominator, what form is this? A plus b into a minus b. So I can write this as 1 minus x to the power of 4. And that is your answer. Okay. Move on to the next problem that I gave you here. What is the problem that I gave you next? Sine log 3x. Last one was sine log 3x. Again, by chain rule, we'll differentiate. Now, Debanjan, you'll tell me so that you can how to do the differentiation, so that you can revise whatever we have done. Tell me. Yes, tell me how to differentiate this. Try, no problem. Even if you're wrong, I'll correct you.
So cos, bro.
Tell me cos.
Of sine will be cos, then ddx of sine into log 3x.
Again. Tell me step by step. Okay. Try, do it in your mind step by step. You'll not be wrong. Don't be in a hurry to differentiate. Tell me step by step. First, you see an
So
outside
cos
sign.
log 3x.
Cos of sine log 3x. Okay. And then
ddx of sine log 3x.
ddx sine log 3x. So now how to do the second part now? Tell me how to do the ddx part. The ddx part. Tell
Cos
me.
x of
Cos of
cos x log Oh, sorry, cos only. Cos
Cos
of
log
log
3.
3
Okay, cos log 3x. And then
ddx of log 3x.
ddx log 3x. And then tell me, and then after that,
1 by 3x.
yes, first to differentiate log, so you get 1 by 3 into what else? ddx 3x. What you have inside the log, isn't it?
Hmm.
That's it. Now this problem is done. ddx 3x, you know, is 3. So this is 3x cos sine log 3x cos log 3x whole divided by 3x. So this 3 and this 3 cancels. You simply get this is your answer. Okay, so x sine log 3x cos log 3x by x is your answer. Let's finish this exercise today, whatever little time that we have, so that we can start with the next exercise, differentiate. The next important problem for you will be cos log x whole square, and next is log root 1 minus x by 1 plus x. Third is ln x whole square. Ln is natural log. Then you have log. This is also important. Okay, this is, we'll come back to this problem later on also. Log sec x by 2 plus tan x by 2. And number 5, you have logs sine root x square plus 1. Number 6, you have log root a plus x plus a minus x. Root a plus x minus root a minus x. Okay, and finally you have the last one here. Okay, we will do this as a problem. We'll do this separately. Last one. Okay, so let us proceed with these very quickly. First one, y is equal to cos log x square. Y is equal to cos log x square, in fact. So if you want to differentiate this, first you differentiate cos to get minus sine log x square into ddx of log x square, right? Now this is minus sine log x square into, what is ddx of log x square? It is twice log x. First we differentiate the power. So twice log x, nx to the power of n minus 1 into the ddx of log x. Okay. Next is minus sine log x square into, now ddx log x is 1 by x, right? into twice log x 1 by x. So you have minus 2 sine log x square into log x. Put this within curly brackets so that there's no confusion that this log product that we are taking is multiplied by this entire thing. Okay, so that is why I put it within curly brackets, divided by x, and that is your answer. Second one, log root 1 minus x by 1 plus x. 1 minus x by 1 plus x. Okay, now see, you can differentiate this directly, uh, but it would help a little maybe to you know remove a radical, or you can differentiate this directly also, I think. Yes, it will be easier to differentiate directly. Yes, so therefore let's differentiate directly. Dy dx is equal to, but before that, just remember one thing, that ddx log x can also be written as half log 1 minus x by 1 plus x. Is this okay with you?
Yes, sir.
It can be written. Okay, now we can differentiate this by your whatever rule that we have, is equal to half ddx of log 1 minus x by 1 plus x. Okay, so now half ddx log of this, take the denominator. First of all, differentiate the log. What is this? You'll get 1 by 1 minus x by 1 plus x, right? And
1
then you
plus x by 1.
differentiate what is within the log, 1 minus x by 1 plus x. So here you get half, no, sorry, this is not ddx. So this is half of all this. Okay, now it's okay that ddx was extra. So this is 1 plus x by 1 minus x. Now you can differentiate this by u by v rule. 1 plus x ddx 1 minus x minus 1 minus x ddx 1 plus x whole divided by v square, which is equal to half 1 plus x by 1 minus x, and you have 1 plus x, and 1 ddx of 1 minus x is minus 1 minus 1 minus x, and ddx of 1 plus x is simply 1. It remains like that, divided by 1 plus x whole square. So now what happens if you see here, this 1 plus x cancels here with this. So 1 power goes in the denominator. So now let's simplify the numerator now. Numerator you get minus 1 minus x minus 1 plus x. And the denominator, what remains is twice 1 plus x into 1 minus x. This 2 cancel. So you get minus 2 by twice 1 minus x square. So this again cancels. You get minus 1 by 1 minus x square. Or you can, which can also be written as 1 by x square minus 1. That's it. Okay. Let us now move on to the next problem that I gave you. It is ln x square. Let y is equal to ln x square. Therefore, dy dx is equal to ddx of ln x square. First, you will differentiate this ln, right? To get 1 by ln x square into the ddx of ln x square. Okay. Next, 1 by ln x square. Now we differentiate ln x square. First, you differentiate the power. So nx to the power of n minus 1 twice ln x the power of 2 minus 1. Or you can simply write ln x. And then you differentiate what is within the power. That is ln x. Right? So now you get twice ln x divided by ln x square into ddx ln x is 1 by x. So what happens here? This ln x and this power here, one power goes from the denominator. So you're simply left with 2 by x ln x. And that is your answer. Or you can also write this as 2 by ln x to the power of x. Okay. By power rule of logarithms, we come to the next one, number 3. Number 4, in fact. Log sec x by 2 plus tan x by 2. Log sec x by 2 plus tan x by 2. Okay. So here you have dy dx. This is ddx of log sec x by 2 plus tan x by 2. Differentiate this. First you differentiate log to get 1 by sec x by 2 plus tan x by 2. And then you differentiate what is within the log. Sec x by 2 plus tan x by 2. So now let us move our differentiation within the log. 1 divided by sec x by 2 plus tan x by 2. So ddx of sec x by 2 is how much? ddx of sec x is tan x, sec x tan x. So ddx of sec x by 2 will be sec x by 2 tan x by 2 into the ddx of what is within x sec, what is within sec x by 2. Is this clear to you?
Yes, sir.
Now here ddx of tan will be sec square x by 2 into the ddx of x by 2. Okay. Now we shall simply simplify this. 1 by sec x by 2 plus tan x by 2, and here ddx x by 2 you know is half. Is half sec x by 2 and x by 2 plus here also you have half sec square x by 2. Okay. So now what you can do here is you can take sec x by 2 common. In fact, half sec x by 2 you can take common. Half sec x by 2 you can take common. What are you left with? Tan x by 2 plus sec x by 2. Isn't it? And in the denominator you have sec x by 2 plus tan x by 2. So what happens? Cancels. You simply get half sec x by 2. Clear this problem?
Yes, sir.
Okay, so last two problems. Let's finish this quickly. 5 is log sine root x square plus 1. Oh, I think I have one more. Let's see if I get time. So this is number 5. to log sine root x square plus 1. That is what your question was. Okay, we'll differentiate this by chain rules again. Dy dx is equal to, first you differentiate this log to get 1 by whatever is within the log sine root x square plus 1. Okay, into the ddx of whatever is within the log. We get log sine root x square plus 1. Next, 1 by log sine root x square plus 1 into ddx of log of this is, take you differentiate this log, so you get 1 by sine root x square plus 1 into the ddx of sine root x square plus 1, right? So what you get here is 1 by sine root x square plus 1 log sine root x square plus 1, okay, into ddx of sine root x square plus 1. First you differentiate the sine to get cos root x square plus 1 into the ddx of root x square plus 1. Next, cos root x square plus 1 divided by sine root x square plus 1 log sine root x square plus 1. ddx of root x square plus 1 is, first you differentiate the radical to get 1 by 2 root x square plus 1, and then you differentiate what is within the radical, which is x square plus 1. So what do you have? Cos root x square plus 1 divided by 2 root x square plus 1 sine root x square plus 1 log sine root x square plus 1, and ddx x square plus 1 is 2x, isn't it? So this, you write the 2x here. This 2 cancels, and that is your answer. So your answer is x cos root x square plus 1 divided by root x square plus 1 sine root x square plus 1 into log sine root x square plus 1. That is your answer. And next problem here is, this was number 5. Next problem here is number 6. Let y is equal to, the function that I gave you here was log root a plus x plus root a minus x divided by root a plus x minus root a minus x. Okay, now here you can differentiate directly, but your work will be reduced to a great deal if you can rationalize the denominator. Okay, so better to rationalize the denominator here. So you multiply the numerator and denominator by the rationalizing factor. Okay, what is the rationalizing factor? Root a plus x plus root a minus x into root a plus x plus root a minus x divided by root a plus x plus root a minus x root a plus x minus root a minus x. So now this becomes log of root a plus x plus root a minus x square divided by, and in the denominator you have a plus b into a minus b, which is a square plus b square. So a plus x minus a minus x, which is equal to log root a plus x plus root a minus x divided by, if you open the brackets here, you get a plus x minus a plus x. A cancels. You get, and this is a whole square here. Okay, so you get log of um, root a plus x plus root a minus x whole square divided by 2x. Now this is log m by n form. So you write it as log m minus log n. So log root a plus x plus root a minus x whole square minus log 2x. Okay. So this is twice log. Now by using the power rule, this 2 should come here, right? So this is twice log root a plus x plus root a minus x minus log 2x. Now it becomes very easy to differentiate. Okay, so therefore dy dx is equal to ddx of all this. Twice log root a plus x plus root a minus x minus log 2x. Now it can be written as twice ddx log root a plus x plus root a minus x minus ddx log 2x. So now how will you differentiate this? First, to differentiate the log to get 1 by root a plus x plus root a minus x into the ddx of root a plus x plus root a minus x minus, and ddx of log 2x is 1 by 2x into the ddx of 2x. You agree?
Yes, sir.
So now this is twice root a plus x plus root a minus x. Now you differentiate this root a plus x, root a minus x. First you differentiate this root a plus x to get 1 by 2 root a plus x into the ddx of a plus x, which should be 1 ultimately. And here you have root a minus x. So this is 1 by 2 root a minus x into the ddx of a minus x. Okay. And you have a minus 1 by 2x into ddx of 2x is simply 2. So this 2 and this 2 cancel. And we have 2 by root a plus x plus root a minus x. Okay, and this is ddx a plus x is 1, so you simply get 1 by 2 root a plus x. And ddx a minus x is how much? Minus 1, right? So this you get a minus sign here, 1 by 2 root a minus x, and you have minus 1 by x. Okay, so now you take the LCM. You have twice root a plus x plus root a minus x, and within the curly bracket you can take your LCM, twice root a plus x into root a minus x, and here you get root a minus x minus root a plus x. Okay, minus 1 by x. Let me just check the answer. Mhm. There should be a negative sign somewhere.